is Nur Izzah Binti Mohamed Diah, and my supervisor is Dr. Sabarina Mat Yunus. Today, I will be presenting my final year project entitled Heavy Metal Contamination and Human Heart Risk Assessment in Fish Sample. So, this is my outline that I will be present after this. Let's get started. Chapter 1, Introduction. For the background of study, consuming fish has expanded for the last several decades due to its nutritional and preventative qualities. Fish contain high level of vitamins, protein, and vital minerals such as copper, iron, and zinc, which are essential to human diet. However, heavy metal pollution in aquatic ecosystem is becoming a serious problem due to the major environmental and health issues. Therefore, numerous studies indicate that the consumption of contaminated fish expose humans to the heavy metal, posing a risk to their health. There are two main problems that inspire me to do these studies. The first one is the concentration of heavy metal in fish will rise due to their ability to bioaccumulate in fish organs, gills, and tissues. The second one is this study is focused to address the issues of heavy metal exposure in some fish species at LKIM Kuantan, Pahang. Moving on to the significance of study, understanding how heavy metal can enter the fish species is important in evaluating their toxicity and accumulative behavior in aquatic life. This study will raise public awareness of the harm of consuming heavy metals contaminated in fish by spreading the information about the human health risk assessment. There are three main objectives in conducting this study, which are to determine the concentration of heavy metal in fish sample using ICP-OES, to compare the concentration of heavy metal obtained in fish sample with a standard guideline, and to calculate the human health risk associated with heavy metal contaminated in fish. Chapter 2, Literature Review. Basically, heavy metal can be broadly classified into two categories, which are essential and toxic metal. A study by Liu 2018 stated that essential heavy metal refer to the metals that living organisms require for fundamental activity like growth, metabolism, and organ development. Meanwhile, toxic metal are metallic chemical elements that can be harmful to the organism with a concentration above the required for metabolic function. Next is the Health Risk Assessment, HRA. It is a common tool to calculate the health risk from the exposure to known amount of pollutant. This method is used to determine the bioavailable concentration of heavy metal and the risk to human. Additionally, Hidayati 2020 analyzed that it is crucial to examine the possible danger of chemical pollutant in food derived from aquatic source using health risk assessment. This study used wet acid digestion method. Approximately 0.5 gram of dry fish tissue were wet and transferred into a beaker. The digestion process begins when the sample are mixed with 8 ml of concentrated nitric acid on the hot plate. The mixture was allowed to cool for a few minutes, and 2 ml of the ionized water and 3 ml of hydrogen peroxide were added. After that, the sample were then transferred into 50 ml volumetric flask and filtered using a wetman filter paper. Then, the sample were ready to determine the concentration of heavy metal using ICP-OES. Next, two formulas from Human Health Risk Assessment was employed, which are estimated daily intake (EDI) and target hazard quotient (THQ). The EDI of heavy metal was calculated using the mean level of metal in aquatic organism and the amount consumed, and the target hazard quotient (THQ) were estimated as the percentage between exposure and reference dosage. The formula for EDI and THQ as shown in the slide. Now we continue with the chapter 4, Result and Discussion. The graph on the left side shows the concentration of essential heavy metal, which is copper, iron, and zinc in the unit milligram per kilogram. The blue bar represents copper metal, and the concentration of copper metal were ranging from 4.0 to 18.0 milligram per kilogram, where the highest concentration of copper can be found in ikan lolong. Next, the orange bar is belonging to iron metal. The concentration of iron metal were ranging from 63.0 to 179 mg per kilogram. And the highest concentration of iron can be found in ikan tamban. For the last essential heavy metal, which is zinc, that is appear as grey bar. Zinc metal concentration were ranging from 17 to 37 milligram per kilogram, and the highest concentration of zinc metal can be found in ikan kembung and ikan selah kecil. For the toxic metal, the blue bar is representing the arsenic metal. The concentration of arsenic metal found in this study were ranging from 1 to 5 milligram per kilogram, and the highest concentration of arsenic metal, which is 5.0 milligram per kilogram, correspond to ikan kerapu. Next, cadmium metal is appeared as orange bar. Unfortunately, only 3 species of fish sample that contains a concentration of cadmium, which is ikan tamban, ikan tongkol, and ikan kembung, with a value of 1.0 mg per kilogram. Lastly, the grey bar is belonging to lead. The concentration of lead is ranging from 1.0 to 8.0 mg per kilogram, with the highest concentration is found in ikan kembung and ikan tamban. Moving on to the objective 2, which is to compare the concentration of heavy metal in this study with the standard guideline. As we can see in the table, there are a few highlighted concentration of heavy metal that exceeding the permissible limit suggested by WHO, FAO, and MFA. The concentration of iron in fish sample, ikan tamban and ikan tongkol, was found to be higher than the standard guideline, which is 100 mg per kilogram. Besides, the concentration of arsenic in all fish sample were found to be higher than permissible limit, which is 1.0 mg per kilogram, except for ikan selayang, ikan lolong, and ikan kembung. Lastly, the highest concentration of lead found in this study, which are in ikan tamban and ikan kembung, were found to be exceed the standard guideline, where the suggested level for heavy metal concentration for lead by WHO and MFA is 2.0 mg per kilogram. The last objective in this study is to calculate the human health risk associated with heavy metal contaminated in fish. The EDI value for all metal analyzed in this study will range from 0.003 to 0.483 mg per kilogram. For essential heavy metal, the THQ value calculated for all metal in fish species were less than 1, indicating no possible for non-carcinogenic effect. The highest value obtained of THQ for essential heavy metal, copper, iron, and zinc were 0.121 and 0.364 and 0.333 respectively. However, the THQ value for toxic metal in this study were higher than essential heavy metal, which is higher than 1. This implying that consumption of fish species that contain toxic metal can lead higher health risk. In conclusion, this study aimed to assess the concentration of heavy metal in fish sample, to compare the concentration with the standard guideline, and to evaluate the potential health risk. The concentration of essential and toxic metal in this study can be presented in the following order for fish species, which are iron, zinc, copper, lead, arsenic, and cadmium. The measured value for all these metals in fish muscle were found to be higher, with some of it exceeding permissible limits set by WHO, FAO, and MFA. Consequently, this study concludes that fish consumption in quantum might pose health risk, which emphasizing the need for future research on the impact of toxic metal on fish and the overall safety for food for human consumption in this region. Lastly, there are 3 recommendations found throughout this study. The first one is the necessity for new legislation and regulation that aim at reducing heavy metal concentration in fish. The government should implement strategy to address this pollution contributor and mitigate the heavy metal contamination in water and aquatic life. The study also recommend adopting more accurate instruments, specifically favoring the use of ICP-MS over ICP-OES for measuring the heavy metal concentration. ICP-MS offer greater linear dynamic, increased sensitivity, and the ability to analyze multiple elements simultaneously, which providing more comprehensive understanding of heavy metal exposure. Last but not least, more studies should be conducted in this area to better understand the toxic metal, impacts on fish biotic factor, and to confirm the quality of food for human consumption.